Okay, hello, welcome to this Get Started with CyVerse webinar. I'm Jason Williams, and we are starting this month in April with a new series. We have a quarterly webinar that's really designed to get you started using the latest of CyVerse tools and technologies in order to advance your research. So for the next hour, what we planned is a series of informational demos. You can choose to sort of watch along, look along. This will all be recorded and then presented so that you can follow along later at your own pace. I have a couple of slides that will orient us, and then I'll have interactive demos. We are using this Zoom communication media in order to broadcast this webinar. So you do have the ability to chat questions at any time. One of the reasons why we like to do this live is so that we have the opportunity for people to go ahead and ask me questions, stop me, let me show you something perhaps you didn't get or have a question on. So I'm looking at the participants. I see we've got some folks here, and at any time that you have a question there, just go ahead and shoot me a chat and I will go ahead and get to that. Okay, so the first thing I'm going to do is share some slides and then share my screens. I'll mainly be swapping back and forth. And again, all of this content is available in one form or another online, both through the CyVerse Learning Center, which I'll introduce, and also through this video, which will be posted to YouTube shortly thereafter. So let's get started. Okay, and I have already just one question. So let me just make sure I attend to that. 1 second, please. Okay. Okay, and I will adjust that volume for you as much as I can on my end. And I just encourage you to turn up your speakers. I hope that that you're able to hear. So just let me know if you have any further issues. Okay, so let me just share some slides. Okay, and make one other adjustment. Okay, so the first thing I wanted to introduce is this idea of the CyVerse Learning Center. So the purpose of this Learning Center is to give you an online forum in order to just look up anything that you have questions with. You can search it at any time. We post new content there, and we try to make sure it's the most relevant. So if anything else, before we get started here today, please make sure you take out a moment to bookmark learning.cyverse.org. Everything I'm going to show you is ultimately going to be posted there. So you're going to have a chance to just go ahead and make sure that you have that there in case you need it in the future. Okay, so learning.cyverse.org, and we'll come back to that very end. So what about the vision for the project? As a project, we do have a vision. In fact, we probably need to update this. We're more around 60 to 70,000 users, I think, right now. But we have really helped a lot of people in terms of their publications, the courses that they run, and actual really nice discoveries. If you look on the website, you'll see the latest news feed. And the project itself, just to give you a quick background, that's the first just 5 minutes or so of these slides, and we'll get into the demos, is really a little bit of a history now, since this project was funded back in 2008, originally under the name iPlant Collaborative. It was designed to provide support to the plant science community. And then as it progressed and the first tools were launched, it was renewed in 2013. We updated the name to really include not just plants, but really all of the life sciences. And we actually were just renewed for another 5 years of funding, which is really great as far as getting NSF funding back in this past fall, 2018. So one quick message, and out of gratitude, and also out of your, just FYI, we're funded by the National Science Foundation. So we are colleagues and collaborators. CyVerse isn't a commercial entity. We really are your colleagues. And it's more than $100 million in investment that's freely available to the community. So really encourage you to look carefully at what you're able to use and take that, because it has been invested and it's there for you to take without a direct cost. We do appreciate that you cite us in your publications, so there's a little bit of information there on that. One word that I'll use at least a couple times is this idea of cyber infrastructure. What is it? So in one sense, it's stuff that you're already familiar with: data storage, software, high performance computing, and even people, the human resources that go in to supporting you as you're trying to do an analysis, but it's organizing these things so they play well together. We'd say organizing it so that you can solve bigger and more complex problems that you would have been able to without the need of these tools and services. There are a variety of things that we provide. So we're going to give you an introduction to the platform tools and data sets. We also make use of storage and compute, although you won't necessarily directly see that as obviously it's really underneath everything. And then also training and support. And today is an example of just that. The other take-home message is that CyVerse is built for data. So no matter whether you're dealing with microbes, plants, animals, biomedical, ecological data, or different data types for its sequence, image files, we really have something to meet just about every need of data that you could possibly throw at us. And it really is designed to be extensible. So if there's a need that you don't see supported, we can always work with community members to do our best to support those needs. The product stack, again, we won't see directly and touch directly every single piece, but it is important for you to know, even if you are a bench biologist, much like myself, there's some capabilities there. It's good to know as your project grows and expands. So at the very bottom are the hardware resources, the actual high-performance computing systems, the disk space, actually the storage space, databases. What this means is no matter what you're doing, since primarily you'll be interacting with CyVerse in a virtual format, you don't get the constraint of just working on what's on your laptop. Doesn't matter what kind of laptop or how you're accessing CyVerse. Once you launch an analysis, that analysis is launched with the full power of those resources behind it. In the middle are some services, things like authorization to make sure that your data is secure, or search to make sure that you can actually find those data sets. And at the top level are sort of the products, and that's what I'm going to be focusing on today and giving you an idea of how they can be used both in your research and also in your educational goals and activities. We are really guided by the community. So if you look and ask yourself the question, well, what tools are available through CyVerse? We know that genomics is still the big driver of big data biology. So you'll find everything from tools for reference-guided assembly of genomes to SNP calling, variant calling, ChIP-seq. So really the whole host and gamut of things you typically expect to work with genomics, but it's more than that. But of course, I wanted to highlight that we do have those key workflows available. The other sort of background information before I get into demos is that we are a collaborative institution, primarily between the University of Arizona, Texas Advanced Computing Center, UT Austin, and also where I'm at Cold Spring Harbor Laboratory in New York. There's also other CyVerse extensions, probably the most mature of which is CyVerse UK, but there are actually some other international projects which we hope, as they come to fruition, we'll also be telling you more about. So let me now start to dive into the actual pieces. You may have signed up for a CyVerse account. Someone told you, hey, look this out, look and see what it can do for you. But I want to give you a little bit of a chance to explore in depth, especially some pieces maybe you didn't know about. So we think of our cyber infrastructure as analogous in some ways to Lego blocks. We built many different pieces that you can put together, and we hopefully have built them in such a way that you can build what you want and not have too much difficulty in doing that. The first major piece, and one that I'll give a demo, is the data store. If you can't upload, share, and store data, you're going to be stopped at the very first point in your analysis. So every CyVerse user gets an automatic 100 gigabyte allocation. There's no hard limit on that, but if you do want in excess of 10 terabytes, pardon me, we will ask that you fill out a little form for justification. Those data are automatically backed up, and we have really easy ways to upload, download, and share. And I will be showing that and sharing that with all of you in a demo in just a moment. The other is the discovery environment. So this is a bioinformatics workbench, if you will, that you can run almost any bioinformatics application, but without the command line. We know that most biologists may not be trained in Linux and Unix. So many of the bioinformatics apps are only available through those interfaces, and so you can actually use a great deal of them through the discovery environment. One recent extension to this discovery environment is something called Vice. So if you are familiar with using RStudio, if you're familiar with using perhaps Jupyter, Jupyter Notebooks, Jupyter Labs, or RShiny, these are examples of tools that you can run right from the discovery environment, and I'll give you a short demo and introduction to those as well. The cloud computing, we had one of the very first open science clouds called Atmosphere. Gives you access to hundreds of virtual machine images. If you've never used cloud computing before, well, you probably have, but if you've never used it for your science research, I'll give you a short demo and perhaps convince you that it can be both effective and easy to do. Some things we won't give demos on, but it's good FYI knowledge, are the Signs API. So if you do have developers or you're a developer yourself, there are really custom ways to consume the cyber infrastructure that we've made available. And so the APIs are a way to do that. DNA Subway, something that we developed here at Cold Spring Harbor, is definitely a wonderful tool for doing educational workflows. We have some nice YouTube videos. I won't be presenting a webinar, demo on that, but if you have questions, you can ask me. And of course, on learning.cyverse.org, you'll see more. BISC as well for image data analysis and management, another fantastic tool for working with those data sets. And now what I'm going to do is actually transition to the demos. So the very first demo is going to be about getting data into CyVerse. As I mentioned, the CyVerse data store is available to you. Any type of file related to your research, you can move those files between the different platforms, you can automate, and you can share with your lab members, collaborators, and communities. There are three basic ways to access. Sometimes, you only want one way, but in this case, we have a variety of ways because there are different needs of our different users. The easiest ways, which I'll demo, are a tool called CyberDuck and one called the Discovery Environment, which is also an analysis platform, and also the command line. So I'll show you all of those in just a few moments. The Discovery Environment, just FYI, we use that for upload and transfer small files, but it's really the best for sharing data and managing your data sharing settings. For just bulk file transfers, almost nothing beats CyberDuck. It's really easy to use, and it's a drag and drop interface to the CyVerse data store. And if you're used to working at the command line, then in that case, you can do almost everything you like using another tool called iCommands. So what I'm going to do now is put the slides aside for just a moment, and I am going to take you to the CyVerse Learning Center, and that's at learning.cyverse.org. I just want to make you aware, and also assume that you have been to the main CyVerse site. So if I can actually type correctly, I'll get you there as well. The main CyVerse site has links to all of these things. So if you do click on Learning here, you'd also get to the CyVerse Learning Center. But since the name, I hope, is pretty easy, learning.cyverse.org, we're going to go right there. So at this point, everything I'm going to talk about can be found in this data store guide. So not that you necessarily have to follow along with me, but I want you to know that if you go to the data store guide, you will find instructions for everything that I'm going to do here at a decent speed. I'm not trying to lose anybody, but we do want to get through this whole portion of time that we have. So the very first thing we're going to do is this drag and drop data transfer with CyberDuck. CyberDuck is actually a standalone tool. We do not build it in-house, but it is freely available for you to use. You can make a donation to their project, but it is open source. And the first thing you'll do is download a copy of CyberDuck. It's available for Windows and for Mac. And you also want to download a CyberDuck configuration profile. So this is essentially a bookmark. I've already done this. I'm not going to do it here, but it literally takes less than 5 minutes to do the download, and just the very first time, enter your CyVerse username. You'll also enter your password the very first time you use that, and then typically it will be saved and you won't have to worry about doing that again. When you open CyberDuck, and I'm going to go ahead and open CyberDuck on my computer, here I am already connected to the CyVerse data store. So typically, I think it takes somewhere in the order of 30 seconds or so to connect. I'm on a wireless connection, so I'm not going to do really big transfers. But this looks just like a file browser that you might have on your system. And so if you wanted to move a file from the CyVerse data store into your, let's say, my laptop in this case, it literally is drag and drop. So I saw a zip file, and then a new box opens that gives me a sort of record of past uploads and downloads. Also shows me the progress. I can interrupt a transfer, pause it, restart it, etc. What you would expect on a very good internet connection is to transfer about 100 gigabytes of data in about 30 minutes. So let's say you are working on your RNA-seq analysis. Probably the first thing you want to do at CyVerse is go ahead and do this CyberDuck transfer or CyberDuck setup, and then go ahead and start transferring these files. There are more details on the Learning Center, but in CyVerse.org you can also go ahead and create new folders so you can manage your upload and data fairly easy. And although I'm not going to do it here, if you wanted to take a file that you have downloaded or that you have already locally, you literally just drag it to the location or to another folder on the CyVerse data store. Now, right now, even though I'm wireless, it's just taking a few seconds really because it's authenticating. Once it authenticates, the file is actually there in literally a blink of an eye. If I want to go ahead and upload that file to another place, I literally drag it back up. I can see the arrows up because I am uploading, and it will go ahead after it authenticates and do that upload also fairly quickly, and you get an idea. So really, there is very little more to show you other than that CyVerse.org is very effective at doing that drag and drop and moving back and forth. Now, the next thing I'm going to show you before I go to the discovery environment is how to do this at the command line. So back here, what it tells us is that we can do command line transfers with iCommands. So iCommands is, again, another third-party tool. We do not develop it. It's developed by the iRods project, and we also use that software in order to that's actually the software that we use for our entire data store system, and it provides a number of advantages. What we're going to do here is assume that you've already installed iCommands. It's available for Linux and Mac, and technically, now that Windows also is able to run Bash, you should be able to get it to run on Windows as well. So let's assume that you have downloaded, and there's a very first-time configuration, which is fairly simple. If you know the command line well, Linux well, this won't take you any time. Even if you don't know the command line, you want to try it, there's very few commands to go ahead and get started with that. So I'm going to go ahead and close CyVerse.org since I am not going to use it anymore for this demo. And let's go later. I'm going to go ahead and start a terminal, and let's start one that is a little bit higher contrast. Okay, excellent. Okay, so I have a terminal on my screen, and the iCommands are roughly based on Linux commands. So if I want to transfer a file, or actually, let's say if I want to list the contents of my directory, it's an ls, but if I hit ILS, what it's going to do is show me the contents of my CyVerse data store. So just a moment ago, I was viewing this in CyVerse.org, and it's essentially the same exact information that I viewed a moment ago. If you look back on the website, it gives you not only some tips, but also the commands that you want to use in order to make use of this. So if I wanted to get a folder, it would be a command called iget, and I want to be recursive since it's a folder. I want it to give me the progress and to be verbose, and then I can say get the .vcfs folder and then download it to my desktop. Okay, and what is happening is you can see on my desktop there is a VCFs folder, and the progress of the download is reported. And again, using iCommands, you would expect that in a half hour you'd be able to transfer 100 gigabytes of data. So it's fairly quickly. It's multi-threaded, so depending upon the size of the file, it will go ahead and determine how many threads and connections to open, and you'll be able to do that. I'm on wireless, so it's not the fastest possible, but you do get the idea that you can do that. And once you have iCommands installed, if you're an experienced Linux user, you can do things like an IR sync to synchronize collections of data, and so on and so forth, metadata, etc. So do check out the learning.cyverse.org, where there are a number of notes that give you more information on that. But let's return to something that's a little bit more practical for everybody, which is data sharing. And I'm going to go ahead and go to data sharing and then talk about another tool that we want to introduce, and which we're going to talk more about as a data analysis platform, which is the discovery environment. It's linked here. And if you go to the CyVerse homepage, and if you click on Analyze or Products, I think they'll all introduce these products. So I'm just going to go ahead and click on Analyze. And it'll take me a link to the discovery environment, so you can launch it and get there. I've already logged in, and this is what it looks like. You can think of the discovery environment as a sort of a virtual workbench that enables you to carry out your analyses. When you first log into the Discovery environment, you have preferences, and then you do have some help there. Thank you. It looks different on my screen and your screen, so I couldn't know that it was muted. When you do click on the data window, you have a home folder which corresponds to your CyVerse username, and that is actually the things that we just saw a moment ago, both in the interface iCommands and also in CyberDuck. So everything is right here. When you, let's say, check a file, put a check mark next to it, you get information on the right-hand side, like when it was modified, who owns the file, etc. And what I want to focus on here is thinking about the data store for sharing data. So here is, in this case, a PowerPoint, it looks like. And let's say they want to share that data. Let me remind you that all of this information about sharing data and what to do is right here on learning.cyverse. So if I go a little fast, be confident that you can refer right back to it. Okay, so let's say I've selected a file and I want to share that file with somebody. Well, I can go up to the Share menu and I can say Create a public link. There's the file that I want, and if I click Create, what it will do is it will create a URL that I can now give to anybody. In fact, they don't even have to have a CyVerse account. I can say Show that link and copy to my clipboard. And what happens now if they take that and were to paste it into any web browser, it would go ahead and open up a dialog and invite anybody to go ahead and download that file. So this is a really easy way to share small files. We wouldn't recommend sending really large files in this way, but it's quick and convenient. It's kind of like a Dropbox like links. Anybody who wants to have access to that file could. Now, suppose that you decided later on that you don't want to share that file anymore. You could go back to that menu, go to Share where it says Create Public Link. And since this one already has one, I can go in. If you look next to it, there's this little delete icon. If I click on that, the link will be deleted. And now if somebody were to try to access that link, they'd no longer have access. So that's a quick way to share files, and it is limited to files. So what happens if you want to share a folder, or what happens if you want to share a really large file? Well, in that case, we do recommend and actually require in these cases that they do have a CyVerse user account. So let's say I have a folder called RNA-seq. Maybe it even has some big data in it. So I'm going to go ahead and select that. And then I'm going to go to the Share menu, and this time I'm going to say Share with Collaborators. Now, what I want to do is I need to enter the username or the actual name, first and last, of a person who has a CyVerse account and find them in the system. So I'm going to enter the name of a colleague. And I can already see there's the colleague's name. There is the affiliation. So he's here at Cold Spring Harbor. And now I can decide what level of permission. Now, if you're familiar with Unix permissions, then you might already have a head up. But if not, if we go back to the explanation here, there's a little chart to give you an idea of what those permissions enable you to do. Someone with read permission can essentially read and view and even download. Own permission, you have to be careful because they can do everything, including delete. So if I were to go ahead back to Discovery environment and say, I trust Cornell and he can own that, what I would do is click Done, and then they would have access. I'm not going to do that here because I do use his name for every single demo, but you get the idea. The same thing is true if I want to revoke those permissions or change them. I could reopen this menu, I could change the permissions, or I could click the X, and then once I'm click Done, I get a notification that whatever change I've made have been updated, either changing permissions, revoking permissions, sharing, etc. When something is shared with you, you will get a notification. And that notification, I don't know how many I have to go to see all notifications. That notification will easily guide you to where those files are located. So, okay, it looks like somebody shared something with me, or okay, shared with me. Maybe that was two things in reverse. I have to go back and see if I find something. But if you don't have anything immediately available, this is just an easy way to search. You can also just go to the Shared With Me folder. And you might want to know what their username is, but in the Shared With Me folder are every user that has shared something with you. If you click on your Shared With Me, you will undoubtedly have a bunch of things there, only because there are some things that are shared with everybody, and so you could share that way. So what I hope I sort of highlighted to you is that it's fairly easy using CyVerse so far to upload a file and then also to share that file. You can think ahead to what you do next. So you'd be able to, for example, create a folder and then give other people, your lab members, your collaborators, access to that folder. You could choose, maybe undergraduates don't have own permission. Maybe make sure that the graduate students that you all are able to see and own all files so that there's no doubt as to where things reside. One feature that I don't have time to go into, but that's truly excellent, is the metadata. So if you look for any given file, it's really impossible to name files and folders with infinite numbers of underscores. But essentially, with the metadata capabilities, if I go and mark up my files with metadata and I want to search. So let's say I want to search, well, I need to actually add a term. Let's say that I want to search metadata and I want to say the attribute genus, and I want to say the value is Dioscorea. Okay, what's going to happen if I click on search? Although I haven't showed you how to mark up with metadata just yet, I'll give you a quick peek at that. I get the idea that I can go ahead and quickly edit things. So let me go and look and view the metadata of this file. This particular file, I've added metadata to, and I've added my own arbitrary metadata under additional. The genus is the attribute, and the value is Dioscorea. If I want to go ahead and add another, if I said something like experiment or experiment name, and the value is, April RNA-seq, whatever it is, and there's no unit, so I could have, that blank or NA or etc. And spelling it well would be good too. But you get the idea that I can arbitrarily add as many columns, and in fact, I can arbitrarily add a CSV file that contains metadata arranged however I want. Now, to be a little bit, I'm not going to say that, better than that, be aware that we have templates, and these really come into play, for example, when you're submitting your data sets directly to NCBI, which you can do through us. These are all the NCBI approved metadata templates. So, for example, you can make sure that your data are already marked up in the way that NCBI requires when they do the submission. And you can handle all that. There's a tutorial on that, so please check that out. Okay, so let's keep going because we do have a lot to show, but I want to make sure, and I'll take any questions as you have them, that you have a little bit of an idea that we can do these things with data. Okay, so I'm going to go back to my slides for a moment and just move along to analyzing the data. Okay. All right, so we did that demo, and now we're going to talk about the discovery environment. We're already in the discovery environment, just a little bit of orientation. So it's a platform, which means that you can run almost any bioinformatics application, and it's integrated with all of our computing and data services. And it's also user extensible, which means that you can add your own applications, and there's a variety of ways that you can do that. The data window we've already covered, really upload, download, sharing. Apps is what we're going to do next. You're going to see what applications are there and how you could access those, and then also how you can monitor an analysis that you've launched and get a job history. So let's go into that. We're going to do a quick demo where we're going to just create a multiple sequence alignment using this thing called Muscle. Very common program, not a lot of parameters that we're going to be concerned with today, but something that gives you an idea of how overall the process works. Okay, so back to the discovery environment. And I just want to let you know, so we have some sample data, and this follows, if you go back to, let's see, the Learning Center home, and there is a tutorial, or rather a guide on the discovery environment, and that will take you through essentially the same steps that I'm going through right now, so you have an idea of how that works. Okay, back to discovery environment. I want to say that we do have some sample data, which actually, let's go to my favorites, because you can also star. If you look next to your different files, those little 3 black dots give you a little bit of extra information or abilities. So here in my DE walkthrough, looks like I have, it's going to navigate me to that. And I have this file called DE sample plants. I probably have another copy of it, which I'm actually going to use. But just to give you an idea, here is our input file. Okay, just some unlined DNA sequence in plain text. So I'm going to go ahead to apps where I'm going to see applications. All right. So these are the list of applications that are available. If I look, these are some applications that I've modified. But if you search either by topic, biology, genetics, epigenomics, there are some filtering and annotations that go along with these that could help you to find some things. You could search by operation, but I'm just going to go ahead and search apps and type in the word muscle. One little caveat, there may be applications that have very similar names, so there may be different versions of those names. And so it's a very good idea to go ahead and click those dots and favorite the applications that you like. But we're going to use this one called Muscle 3.8.31. I'm going to click on it, and then I'm going to close the application window because I don't need that right now. All the applications in the discovery environment, with the exception of Vice, which I'll show you in a little bit, look something like this. So if you understand how this looks and works, then you basically understand how to use any other application. I'm going to go ahead and add some comments. I'm going to say this is demo for the April Get Started. And I encourage you, one of the deficits of using a point-and-click interface is keeping notes on what you've done. And we track a lot of that for you, but taking notes everywhere you can is really important. I don't need to change my output folder. So this is where, by default, my results will go. Everyone should have an analyses folder where default you will send your outputs. You can change this default. So you can go to preferences. So if there was the Williams Lab folder, I might ask everyone to make sure their analyses by default go there. But for now, I'm going to use this accordion menu. So see these arrows on the edge here, and these two are starred, means it's required. So I'm going to browse for my sequence file, and it automatically opens up to the last thing I used, which will probably be correct in this place. I wanted that DE sample plants file, so I'm going to say OK to that. And for the sequence type, as we saw, this was DNA sequence. I'm going to say OK to that. I'm going to click Launch Analysis. When I click Launch Analysis, I get notifications that my analysis has launched. You'll see also that I get an email when it's done. That's another thing that you can go to your personal preferences and decide how you want those things and notifications, etc., to happen in your preferences. But actually, to see how things are happening in a little bit more detail, if I click on Analyses, that's going to show me a history of all of my analyses, current and past. And so I see currently that I have this muscle analyses and the status is running. While a job is running, there's not so much I can do except to cancel it. So if I was dissatisfied or something went wrong or I knew there was a problem, I could select it. And then up in that analyses menu, I could decide, well, I need to cancel that or etc. I'm not going to do that. I actually want it to finish. But let me show you some other features. Some analyses may be somewhat complex, and you don't want to do a whole lot of pointing at, you don't want to do a whole lot of pointing and clicking your way through lots and lots of boxes. Let's say you have an analysis that you launched before and you want to pretty much use something very similar. I can go ahead and click on a previous analysis, and I can do a couple things. One, I can go and say relaunch. And when I click on relaunch, it'll go ahead and open that analysis, except it will already be pre-populated with everything that I did the last time. And I could go through and I could just make, edits only to the options that I wanted to edit. So I can always relaunch it. The other thing is for analyses, I can go and I can also say view parameters, and then I get a text file that's created. So I can actually see what were the file inputs, what were the names of the files. So I don't have to guess about things. And this makes that point and click analysis much more reproducible. I could save that to a text file if I needed to. As I saw, let me uncheck that. I actually had, let me refresh this, and you may need to refresh to see the updated status. I did see that my analysis was completed. So if I go ahead and click on the analysis name once it's complete, it'll automatically guide me to the output of that analysis. So I won't have to guess as to where those results are. And if I click on them, there you have it. Wait for it to pop up. Okay, perfect. Aligned sequences. So you get the idea of how that runs, that you get those analyses, you can see your past analyses, you can see the history of them, etc. So it's a fairly nice workbench. There's also searching so that you can go through and search. Maybe you had notes to yourself in a particular analysis and you want to find the one when you use a certain input or etc. So you have all of those things there. Really convenient way to go and take a look. Okay, so I'm not going to go much deeper than that in terms of how to run an analysis. It's enough to get you started, and then you can go through and look for the applications that you feel you want to make use of. But let me tell you another bit of some other tool that's not quite as visible. I think we're working on a button for it, but this is called Vice, and I have some slides. So let's see. Well, VICE, which I should go back to the other slide actually, just to give you the acronym again, stands for this Visual Interactive Computing Environment. So it is a way to launch some computing environments like RStudio or Jupyter Notebooks, which you may or may not have some familiarity with, but it's a really popular way of analyzing data and really one of the common tools of data science. So just to quickly recap what VICE allows you to do, there are other tools online that do allow you to do some of these things. Let's say you're using some things really advanced like Spark or TensorFlow, or using one of the great services like MyBinder, which allows you to use Jupyter Notebooks. Many of those have data limits, and we don't. It's a secure environment to use these applications. You can customize it. You can run, I believe these have a 48-hour running limit, so you can really do longer analyses. It scales well, and you can share these apps and analyses. Jupyter is a well-known project for working in a notebook format. I wish I had a whole webinar to talk to you about Jupyter if you don't know what it is, but it is definitely a really nice way to document and use code and make it very explanatory. RStudio is similar in that way. It's specialized for the R computing language, statistical language. Also, with the R Markdown notebooks, you can also make it quite nice narrative. So let me just show you these things and give you an idea. There are upcoming webinars. In fact, there's a webinar this Friday, I believe, on working with nanopore data, and I believe they'll be using notebooks. I don't remember if it's going to be I think it's a Jupyter notebook. So let's go back to the discovery environment, and under applications, you can search for applications. There'll be probably a better way to find it, but if you search for Jupyter, as an example, what you would find are, if I want to launch a Jupyter Lab instance, I could go ahead and click on Jupyter Lab. And then really the only parameters I want to do is I want to select ahead of time the data sets that I want to import or make available through my Jupyter Lab. Now, the reality is that you may have packages to install, libraries, etc. And so what you may want to do when you're working with the Jupyter Lab instances that we're seeing, or if you want to learn how to customize them, is go back to learning.CyVerse.org, because it talks about how to make a more custom environment. And there are other ways to import data, but for right now, it's really as simple as clicking Launch Analysis to get a Vice environment started. I've already started 2 of them, so let me just give you an idea how they look. Number 1, when they're ready for you, you'll see them in the notifications. So I chose a ball gown session for doing RNA-seq analysis with RStudio. So if I click on Access Running Analysis, what's going to happen is it's going to open a window. I can type in my password, which the default is going to be RStudio and RStudio. And then I am actually going ahead and using RStudio in the discovery environment. So I can go ahead and take a look at that. You can see actually I was testing it earlier. So here's my previous console history. I was just looking and seeing, if I wanted to install a package, let's see, or if I look at what packages are installed, I can go ahead and see that there are packages installed, and I can load libraries. So it's really a whole RStudio environment that's running right now through the discovery environment. I'm not going to do anything cute. I could do, maybe make a plot or something, but you get the idea that you have the ability to use RStudio just as you would on your own laptop. The advantage of using it here is that you may be working with data sets that are much larger than can fit in your laptop. You may have something that's going to take a couple hours to compute, and why make that run on your laptop when it can be running on the discovery environment while you are waiting for it. And also, since you can create a completely reproducible environment, you can set up the version of R that you need, the version of packages that you need, and you can make it really easy for somebody to run your script or your R Markdown notebook. In a similar way, if I go back to that discovery environment, I can also see under my notifications, I've got Jupyter running. So I can go ahead and click on that. It's going to open up a link. And then from there, I'll give it a chance to load. I've got Jupyter running. So I can go ahead and launch, let's say, a Python kernel. I can, go ahead and do anything. Here's my new cell, right? And I can start working in Python. And do anything they would normally do. I didn't load a really fancy notebook, but you get the idea that you can go ahead and create and manage notebooks. You can log into the CyVerse data store and give you a chance to import data that you needed to import. You can go ahead and open up a terminal. I go back to here and say that I need a new terminal, and I can say, well, there's Conda installed. For those people who are familiar with the package manager Conda, you can install new packages and libraries and really do your analyses. So it's a fantastic way to make use of these data science tools. What you can do once you have, if you know when you have something running in your analyses, you've done some work and then you want to get it back, you can go ahead here and click those dots next to your studio session or your Jupyter Notebook session, and you can say complete and save outputs. You can actually store all of those analyzed files back in the CyVerse data store and have them. So it's a fantastically flexible way to go ahead and work with any of the applications that you might use in Jupyter or RStudio, but really in a way that you may not have been able to do before. So I'm a great fan of that. Okay. We have one more product that I need to show you. So one more demo, just a few more slides, and then believe it or not, we're at the hour very shortly. So the final thing to show you is this Atmosphere. So Atmosphere is cloud computing for life science. There are hundreds of virtual machine images. If you don't know what that is, I'm going to explain it to you in just a second. Allows you to fully customize your software setup, and it's integrated again with all of our data and compute resources. Let me give you a couple of pieces of terminology that you may or may not be familiar with. So let's use an analogy because I need to explain the word image. Let's say that you bought a computer and you have the original computer and you have the new computer. So from your original computer, you might take all your files and folders and transfer them onto a hard disk so that you have a copy and move them over. But there's another type of file that you could make called an image file. And an image file is essentially a copy of the entire computer system, the operating system, all of the subsequent installed programs and their configurations, etc. So from a hard disk, that you have a USB disk, documents will always be just documents, but an image file can actually be cloned into a complete system down to the picture of your cat that you have on your desktop. So when I say image, I'm talking about a complete architecture of a system, software architecture, the operating system, all the installed programs, etc. Image. Okay, one other piece of jargon, which is instance. So in the CyVerse cyber infrastructure, we have disk space, we have CPU, we have RAM. And so when you want an instance, you're asking us for a certain amount of each of those. So we'll give you what you asked for, and then you also need an image to actually run software on top of that hardware. And all together, you get what we call an instance or virtual machine. And that's available to you in an IP address, which you're going to connect to, and I'm going to show you. There are some generous allocations available, 16 core, 128 gig RAM, and you can access it through the shell or the VNC. I'm going to show you everything on the web, and it's a really fantastic way to sort of customize what you're using. You can run, again, things that you normally would do on your laptop and your desktop in this environment. Certain graphical programs that you couldn't integrate in the discovery environment, you can run them there. Also, there is no administrative burden. So if you have an administrator or administrative policies, you don't need anybody's permission to install or delete things as you might on a larger system that doesn't belong to you. All right, so I'm just going to give you a quick demo, which is how to launch and connect to an Atmosphere instance. Okay, so let's take a look back here. And this is accessible from, I'll go ahead from the CyVerse website and click Launch Atmosphere. And I will comment that Atmosphere is not automatically added to your CyVerse account. So you have to go back to user.cyverse.org in order to request access for it. And Atmosphere is limited to users within the US. So if you're not within the US, but maybe you have a US collaborator, you can contact us and we can see what we can do. Once you are logged in, you're presented with a dashboard, a history of what you use, what you're using, what you've launched, etc. And you could say, well, I want to launch a new instance. So maybe you want to search by topic. So let's say, I wonder if that is maybe somebody has done, since I've been thinking about nanopore. I don't know if anybody has any of the nano stuff that's there, but I do know, oh, it was there. It just took us a second. It said 0, and then all of a sudden, as soon as I was going away, it looked like it was trying to show me more stuff. Maybe not. Okay, I was going to type in RNA-seq. Because I know there's some instances tagged there with RNA-seq. And let's say, okay, I wanted to use Trinitate. Rather than install that myself, somebody's already put those things together in a way that looks good for me. So I can go ahead and click on Launch. Then I can decide, how much resources I need, and then click Launch. Now, I'm not going to do that now, but you get the idea that within a few moments, you can have access to this virtual computer. It's yours. It runs on your allocation. As you see back in my dashboard, I have a certain number of hours that I can use every month. If you need more, just click on the Need More button and give us a little bit of justification, and we'll try to help you out and get what you need. Now, I already, back in my projects, have a demo project where I've already launched an instance already. You can see it has an IP address. So if I wanted to connect to that, well, let's go back and see the whole details. If I wanted to connect to that, I can copy that IP address. I could open a terminal. Shouldn't have closed my last one. Let's make this bigger. And I can do SSH, my CyVerse username, at that IP address. Oh, and it's one that I've connected to before. So it's like thinks that I'm doing something sinister. Let me correct that for you. Let's see if I remember my password. No, that's not it. Okay, let's get rid of all that. You would not have to do this in general. Okay, SSH into that. Yes. And my CyVerse password. And now I'm into that machine, that Atmosphere machine. But the easier way might be to go ahead and use what we provided. So you have this thing called web shell, and you can click on the web shell without doing all that. And if you are used to the command line, you will be already entered into a command interface that looks very similar, ready to use that machine. Some machines actually have a desktop, so you can go ahead and click an Open Web Desktop, and then you would be able to go ahead and use the desktop of that computer as you would any other computer. You can see what the applications are, accessories, things installed, etc. So you get the idea that you have a fully functional computer that didn't exist 10 minutes ago. It usually takes 10 or 15 minutes to launch, and you can use that to analyze your data. Maybe there are configurations of software installed. Maybe you even want to share this computer with somebody else and sort of work on a project together. So you get the idea that it's quite powerful. That allocation will run until you have no more hours left. So before that point, or let's say you're done for the day, you're stopping for the weekend, you might want to suspend that image or shelve it. But if you run out of data, run out of allocation, you won't lose any data. It'll be saved for you, and you can ask for more resources. But they will refresh at the beginning of every month. Once you're done for sure with a particular instance, then you'll delete it. Be sure that you've transferred those data, and you can transfer them. There's tutorial information on learning.cyverse. You can transfer them back onto the CyVerse data store, which is permanent. Really, the Atmosphere storage is somewhat ephemeral, so you want to transfer it before you're done. If you delete it without saving it, unfortunately, we can't help you there. So you have to make sure you save it. Okay, so just a few last steps, and then I'll take any questions, and then we will be done for the day. So as I mentioned, there's ways to connect using the shell, the terminal. We have the web shell. And I mentioned the CyVerse Learning Center. You can also go back to the CyVerse events page where you'll be able to see more details about upcoming events. One that I want to pitch right now is this new program that we're launching through the CyVerse Learning Institute called Foundational Open Science Skills. It's a 2-week course. If you or your friends, colleagues, whoever are interested in what is open science and how do I get computational skills, how do I make my lab more reproducible, how do I write better grants that are going to be more impactful because they're really in tune with open science, we're going to have a 2-week intensive workshop followed by, extensive support thereafter to help you. And this is really especially useful for people who are new PIs, people who are planning to go down the route of starting their own lab, or maybe somebody who's just really been doing this for a while but hasn't had a chance to get these skills. So if you go to CyVerse.org/FOSS or look at our events, you'd be able to learn more about that. So with that said, we are at time, and I want to just leave a moment for anybody who has any questions or anything that I could show you again. On behalf of everyone who works at the CyVerse project, we want to thank you for signing up for your account and really wish you the best in doing everything that you hope to do with the account in terms of analyzing your data, teaching your students, and making use of these tools and resources. As I mentioned, everyone who registered will be sending out a link once this is available on YouTube. And if you have further questions, you can contact us through a variety of means. One last thing that I should show you, it's worth showing you almost everywhere you'll see on the CyVerse platform. So let me go back 1 second. And in fact, not my slides, but actually, let me go ahead and share my desktop so you can see it all. Back on the many of the things you'll see in the bottom right-hand corner, this little button, which is a live chat button. And so if you have questions and run into technical issues, very often that's the best way to start a conversation with us so that we can assist you with any issues that you might have. Someone who doesn't answer right away, you'll create a ticket, and then we'll go ahead and be able to see those. So I don't see any additional questions in the chat. We'll follow up with that link to YouTube and also a survey that we'd like you to give us a little bit of feedback on how today went for you. And with that, we'll thank you and wish you a wonderful rest of your day. Thank you for signing up for your CyVerse account, and hope to see you in person one day.